Okay, sketching triangles. This is now the second example, and this one is slightly different to the first one we did, because for this question we have to express things in terms of k instead of find an exact answer. So let's read the question. Given that cos of 24 degrees is equal to k, express the following in terms of k. So they give me these three questions that I need to express in terms of k. So that simply means that all your answers will have some form of k in it. We'll have to draw a triangle first of all. Now this angle is given as 24 degrees, not like in the previous example where I had to find the quadrant. I already know that this would be in the first quadrant because the first quadrant goes from 0 to 90 and 24 degrees is in between 0 and 90, so it should be right over here. Okay, then if you want, you could work out this angle here. This one is actually 66 degrees. Okay, I don't think we're going to need that one right now. Okay, so we're going to use this piece of information to fill in the values on our triangle. Now, the ratio for cos is adjacent over hypotenuse. So if we break this up as a fraction, like k over 1, k would be our adjacent value, and 1 would be our hypotenuse value. Now, when you work out this opposite value, you would simply square the hypotenuse, minus it by the square of k, the adjacent value, and then you just take the square root of that. So it would be the square root of 1 squared, which is 1, and k squared, which is k squared. Okay, so that's your opposite value. It can't be simplified further than this. So we just leave it like that. Now we'll answer our question. Sine of negative 24 degrees. First of all, if sine has a negative angle, then sine becomes negative. In fact, the only function that is positive with a negative angle is cos. Okay, so now we need to find out what is sine of 24 degrees. Well, sine is your opposite over your hypotenuse. Now, since the hypotenuse is 1, we can just regard the hypotenuse because anything divided by 1 would stay the same. So this answer is simply negative square root 1 minus k squared. And again, since it's divided by 1, we're just going to leave it like that. Right. Now here we have an angle that's not 24 degrees, it's a bit bigger. So I'm first going to reduce it using one of my reduction table quadrants. And in fact, we're going to use the third quadrant because 204 degrees is an angle in the third quadrant. So that breaks up to 180 plus 24 degrees. And since tan is positive in the third quadrant, this remains positive tan of 24 degrees. Okay, now tan of 24 degrees would be the opposite value over the adjacent value. So it will be the square root 1 minus k squared divided by k. Okay, that's your opposite. This is your adjacent. Okay. Last question. This one's going to be a bit tricky. Cos of 84 degrees. Now, because 84 is already an angle less than 90 degrees, I can't necessarily reduce it further. But I can still break it up. It won't be a cofunction. It won't be a reduction. Because both of those is useless to me now. The only thing I can do is break it up into a compound angle. So, cos of 84 degrees, I'll break up into 60 degrees plus 24 degrees. Now, the reason I'm choosing 60 degrees is because 60 is simply just a special angle, and we know all the values for our special angles. So that's going to be easy. Now, if I break this up into the compound identity, we have cos of 60, cos of 24, minus sine of 60 times sine of 24. So now as you can see, I wrote it out. And all that's left for me to do is to substitute these with the answers. So cos of 60, the special angle, that is a half. Cos of 24, we know that is k. And sine of 60, that is square root 3 over 2. Root 3 over 2. And sine of 24, we said was this root thingy over 1. It's your opposite, your hypotenuse. So since it's over 1, we'll just have the root. And now you are simply going to multiply all your numerators together and all your denominators. Now keep in mind this k and that square root are all numerators. Okay, it's only this 2 and that 2 that is the denominator. And since we have a common denominator between our fractions, we'll just group them together. Excuse my handwriting, but there you go. This is k times 1, which is still k. Then the square root 3 times this square root, we just multiply the 3 with whatever in that root. And the common denominator 2. So there you go. That's our final answer.